Hello, everyone. This is Patrick Tucker, and I'm back again this time to talk about how U.S. Central Command has become a hotbed of innovation and experimentation across a wide range of technologies, swarming, artificial intelligence, but certainly information technology, intelligence, surveillance, and reconnaissance, and maybe even a couple more. Talking today with Skylar Moore, CENTCOM's Chief Technology Officer, and Andrew Moore, Advisor on AI, robotics, cloud computing, and data analytics, also with U.S. Central Command. Thank you both for being here today.
Glad to be here.
Great. So yes, Central Command has been on a tear with a lot of different experimentation efforts. You've got Scarlet Dragon Oasis, Digital Horizon, Red Sands. So my first question to both of you, is there an anecdote that you can come up with that speaks to some event that happened with some of this experimentation that shows how to shift the paradigm from kind of the way militaries operate now to where they could be? Was there a key moment for you, whether it was at Dragon Oasis or Digital Horizon or Red Sands, that really shows, okay, this experimentation is paying off, and now we have a clear idea for a new direction?
Well, one of the things for me which blew me away and completely changed my view, I previously actually testified for the Senate on the state of artificial intelligence in the US military. And that was like slightly more than a year ago. And at the time I expressed, I was really concerned that there wasn't so much bottom-up expertise permeating US military. In this recent Dragon exercise where we got to see bottom-up ideas of using AI in innovative ways, I was absolutely blown away with what many folks in seemingly non-expert parts of the services had come up with. And I realized AI is really democratized in some parts of the US military, at least by what I've seen from CENTCOM.
Yeah, Skylar.
Absolutely.
Yeah.
The example I can give is we're just wrapping up an exercise here. So I think folks have heard about Scarlet Dragon Oasis, which was our exercise in January, and we just finished up the follow-on, which was Digital Falcon Oasis. The intention of these is not to be a single moment in time, one exercise and done. It's a series. It's intended to follow in many ways the best practices of the software community and private sector, which is that you do this in sprints, you do it iteratively, and you repeat these exercises over and over again to improve over time. And I think an aha moment for me was in the past week or so, we've had briefings from folks and each would start with, this capability did not exist 60 days ago. That's the kind of speed that we're achieving here, where we have software developers seated side by side with operators. What started as high-level conceptual conversations about what their workflows look like have turned into real software tools that they're hands-on, they're able to give feedback on. And so I think really those moments of folks across the command who have never really touched software tools in a meaningful way or interacted with software developers, and the speed at which we've been able to get them up the curve and get them the tools that they need has really been encouraging.
That's an excellent point, and this really follows what when I talk to senior leaders, they've said that it's sort of essential for the U.S. military to move in this direction, where we find folks at the operator level and make sure that they have both the tools, but also kind of the bandwidth and the attention and focus on them to let them surface solutions that they're working on. And as you point out, they're developing these things themselves. They have the operational experience to know what they need better than maybe somebody far away in Virginia that has a PowerPoint but doesn't have that experience like in the sand. Can you talk a little bit about the Red Sands experimentation that's been going on? We're reading a lot about Iranian drones and their effects on the people of Ukraine, and Iran is a very fast mover in drones, and you have a counter drone activity and a partnership with Saudi Arabia that I think is really fascinating. What are you learning from that experimentation?
Yeah, so as you noted, Red Sands is an experimentation cell that is focused on the counter unmanned aerial system problem set. It's based out in theater. It's moves location across Saudi Arabia. And I think that, I mean, the two primary takeaways for us is first, as always, the importance of partners. That technology alone is insufficient if you are not bearing in mind the context in which you're using them. And for us, so frequently that includes partners. So if we are not training with partners, if we are not getting feedback from our partners on how a certain capability is meeting or not meeting their needs, then we may put ourselves at a disadvantage. So having that type of cell that integrates a partner directly has been fantastic. The other piece that's been a really interesting and useful learning experience is just, you know, we've said it before, but the importance of getting technology into the environment in which it will be used and in the hands of the operators who will use it is so critical if you want to work through friction points early. There are nuances of the environment. It's 120 degrees out there in the summer. It can be windy, it can be sandy, it can be salty. And so systems don't work the way, hardware systems don't work the way that you might expect them to if you're not trying them exactly where you would want. And then similarly, there are going to be users who are going to be coming from a variety of different places and may have mixed experience or training on the systems that you're giving to them. And so it provides a really unique and bounded opportunity to say, is this system intuitive? Can somebody use it and pick it up after an hour or two of training? Because in some cases, we, again, have folks who have never dealt with this type of system before, never dealt with this type of threat. And so we are able to accomplish all of that with Red Sands, and our partners are able to benefit.
Yeah, I think that's great. And I want to stick on this topic of the environment for a second, because I know, and you obviously know too, that folks at DoD are looking to scale some of what you're doing there across other combatant commands to the extent that it can be scaled across services. There's a possibility of scaling it across services, taking what you're doing there and really seeing how well that can work in the Indo-PACOM AOR, possibly the EUCOM AOR, et cetera. So that's something that we know that they're looking to do. And I wonder if you can talk a little bit on that, and then I want to get into Central Command, that AOR, and the challenges and opportunities there, and whether that is like how that presents maybe tricks in terms of where you can scale that elsewhere.
Sure. You know, I mean, the ultimate proof that the problems that we face and the technological solutions that we're looking at are not unique to CENTCOM is that so frequently I am emailing and calling Dr. Moore to say we have problems about data integration or about cloud usage or about general issues that really are agnostic of even the military. It's something that commercial sector deals with and that Dr. Moore has an exquisite insight into through his own experiences, and his experiences are directly relevant. And so in some cases, it's a mission set that's applicable to multiple folks. Counter UAS, what we were just talking about, not a CENTCOM specific issue. If you look at the drone activity over Ukraine, I think that's a really poignant example of where a problem set is not region specific. But in addition to that, some of the problems that we face about getting all of your data into one place, about being able to analyze it at speed and get meaningful insight out to an operator who may be in a remote location, all of those problem sets are again, really elevated above a combatant command. And so we're hoping to share those lessons learned with other folks as much as we can. And we're really in particular looking forward to partnering with other combatant commands for future exercises to make sure that we're developing capabilities at a pace.
Okay.
Yeah, but if I could sort of supplement that, one of the things which is very interesting is this evolution of software development away from the waterfall technology, which frankly in the commercial sector, it's so old we've almost forgotten about it. But I think defense against unmanned aerial vehicles is the perfect example of the kind of software development methodology where you cannot possibly live by saying, here's the specification of the problem, now go away for 2 years and solve it and bring us the solution. So having experimentation where it's not every month anymore, it's every week you're learning new things or having to play with new classes of attacks. And nature is very good at giving us completely unprecedented situations to practice it in. And it's that, I can't emphasize enough how, I mean, the technology is really interesting. The sensing, the very fast control loops, all the things you can do with directed energy, that's fun. That's of course what I love, but it's really that getting into the habit of you are adapting every day and rewriting the software tomorrow based on what you learnt today. And that kind of life, it's very, very reminiscent of the startup life.
Yeah, but not very reminiscent of the military, at least that's the one that I understand it. So you're kind of, in many ways, butting up against an institution that expresses and seems to demonstrate a desire to change, but is also huge and is governed by rules and laws and things like that that can in some ways prevent change. Can you talk, you spoke a little bit about how bringing in these operators, seeing how fast they iterate on software, seeing how fast they move a new solution into a state where you can actually begin to play around with it has been kind of eye-opening. Are you also learning things about permissions and that command structure and actually accelerating decision-making with some of both the data that you're bringing online, the sensing that you're bringing online, but also learning about how you can accelerate that decision-making just by moving information more quickly from one place to another?
Without question. I think the commander, General Kurilla here, frequently says that innovation is really culture, process, policy, oh, and by the way, technology. With sometimes when you talk about innovation, it's very easy to get locked onto things that you can see and touch. But the reality is that what we're learning is muscle memory about how to do things in a different way. So for the exercise that we're doing right now, there is a muscle memory that we're building of iterating back and forth with a software developer and not saying whatever software capability I've been handed is static and that's just what I have and I have to make do with that. The expectation now is that you can and will poke holes in it, share your feedback, iterate with the team, continue to give your feedback every single time. And that, to be frank, has been a cultural mindset shift because exercises previous have never given people the opportunity to experiment with that type of activity. Another event that we've had that has really, again, built that muscle memory of doing a different process is Innovation Oasis 2. And I can defer to Dr. Moore to talk a little bit more about that. He was one of the distinguished panelists, but we solicit new ideas of any sort from anywhere across the command to come and present, and the group of finalists come and present in front of a panel of industry experts, of military experts, the general himself, and the proof is really that these good ideas can come from anywhere. But I can turn over to Dr. Moore to talk a little bit about that experience as he really played a central.
Yeah, I think that was, for me, one of the turning points was seeing what folks are capable of. So I'll give an example here of what at first sight might look like a mundane use case for information technology, which is organizing all the utilization of transport to move equipment and people around the world. And there's a whole world of bureaucracy that goes on in that, much of it justified because there's huge checks being written to move all this stuff around. And there's very important questions of safety and making sure that readiness of all the equipment is correct. And so one extremely impressive operator working almost entirely just with Excel as a tool figured out very clever ways of reorganizing that information on the fly so that a whole bunch of completely wasted trips were eliminated by very quickly swapping transportation around in ingenious ways. And the thing that most impressed me, and it really makes me feel encouraged, is the techniques he was using were things which I used to teach at Carnegie Mellon University, a technique called constraint propagation, which is a nice way of optimizing resources. This amazing individual had actually kind of come up with this himself. He was using the web, watching YouTube tutorials, figuring this all out, and he ended up with a system which actually worked. In the end, although there were so many stories like this, that's the one we chose to give the award to, because it really exemplified everything you talk about when you say we need a bottom-up information technology organization.
Yeah, and all with Excel. So as a Google alum, that must have been incredibly painful for you, I'm thinking. But
You know what? There are these things called VLOOKUPs.
okay.
People who know what VLOOKUPs are will nod their heads. People who don't will shrug. But believe me, I don't care if it's Google or Microsoft or anywhere else. Someone who does clever things with VLOOKUPs is a friend of mine.
Okay, excellent. Well, so all of that is great, and but a huge part of its value, it seems to me, is how it can help to create new plateaus of joint interoperability, right? Like this is the main thing that the entire Defense Department is engaged in for the next decade is joint all-domain command and control, joint interoperability across services and across domains. And this all that you're saying seems like a great accelerator of realizing that vision. But there are certainly some bureaucratic challenges to joint all domain command and control, and there are some technical challenges. In some ways, it seems to me that the answer to both the technical and the bureaucratic challenges is ensuring very high levels of connectivity. So as you do this experimentation, you're doing it in what a lot of people call a permissive environment. And if you don't feel like it's as permissive as people say, then please let me know. But what are you learning about the need for very high levels of connectivity between operators, between systems, and how do what are you learning about what's possible there if you have that connectivity, and where do you see limitations there in terms of future experimentation?
Yeah, it really brings it back to the original point of you have to test it where you're going to do it, because your question about is permissive really permissive? Sometimes it is, but depending on your location, often it's not. If you're at a forward operating base in a remote area where you don't have more of a traditional network infrastructure to rely on, or if you're on a vessel, if you're on a destroyer, the bandwidth available to you, the capacity available to you is significantly different from what you have here in CONUS. And so for us, being able to test that regularly in non-crisis scenarios is critical, because exactly to your point, you can build these exquisite software tools, you can have all of this data and all of the richness behind it, but if you can't push it to the place or push it back from the place that has the most critical need for it, everything else downstream of that runs dry. And so for us, a huge part of these experiments increasingly include network troubleshooting, building out resiliency, redundancy, not just in the case of the ultimate far side of denied and degraded environments, but even for right now, just making sure that folks have better access to the tools that they need. In addition, we're also exploring what those options would look for if you have fiber cut, if you lose connectivity to any network that you might have outside. And those experiments, again, are important for that far extreme scenario, but there is so much richness and growth that we can do inside of that, even just to make sure that in a permissive quote unquote environment, we have better connectivity than we do.
Yeah, so sometimes people talk about, well, military should be more like Silicon Valley, and that's only partly true. And this question of you're pairing for different connectivity scenarios is, I think, is a perfect example of that. You cannot build your systems for these kind of scenarios, assuming that there's always going to be a central, like, data center, perhaps sitting in Germany and another one in Virginia for you to talk to all the time. So that does lead to very interesting software design patterns where as much as possible, you, within the limits of the actual capabilities of the servers, you're caching information as close to the edge as possible. And it's actually very interesting, but it does mean that a few times folks like myself who've spent a lot of our time in traditional internet companies have been humbled, where we realize some of our design patterns are not applicable here, because we have to make sure that in a world where we lose 20% of communication bandwidth, or 80%, or even 99.9%, the command and control systems still have to always be able to provide information and give advice and alerts.
Yeah, that seems
I'll
like
add one extra note to that. An interesting comparison that we recently had was we talked about quote unquote edge compute and edge devices and edge servers. And we had a couple of commercial companies come to us and say, oh, we know all about that. We have edge devices because when we have folks out, say, delivering packages, they're on their cell phones, and that's edge. And that was a moment for us where we also realized that we have to adjust the way that we use language, because that is not what we mean when we say edge. There is a fundamental difference in assumption around what is built around you and whether you are in the mountains of somewhere very, very remote with a backpack and nothing else. That may not necessarily reflect it. And that's a good learning lesson for us on being clearer communicators of our environments.
Yeah. Let me stick with that for a second, because I think that that's such an important point when we talk about the future of military connectivity versus like regular people connectivity, and that different set of expectations that I as a consumer can bring to what technology can do for me. If I can sit down and access like some large language model that I'm basically a guinea pig for, but like happily, versus what's sort of available when you have to look out for a great state adversary that's in your vicinity that's looking to thwart you in some way or another. Andrew, I'm very curious as to your thoughts on this, because you are so versed in both worlds. When you look at some of these publicly available, very kind of trendy AI capabilities, generative AI, large language models, chat GPT, and all the different sort of follow along, and you see kind of where they are right now, how do you see a military use for those evolving? And what are your concerns?
Very big question. I will try to hold my answer to less than 3.5 hours. So the funny thing is, it's evolving so much for us folks who are right in the middle of it anyway. And nowadays we're talking about the old days, whereby the old days we mean March. So back in the old days of March, there was a lot of concern about what it meant for the fact that these models had to sit on really, really large servers, usually in the hyperscalers. That we've now seen numerous folks, often citizen scientists or folks in the open world, being able to run these large language models on very normal local servers. And so many of these questions which we were frantically trying to work on as to how we can deal with the scaling when the central AI has to live in one location, they're all behind us now. There's still a question of we usually work, I know this is going to sound technical, but I think most folks will get it. We usually work with, in scientific computing, we work with large floating point numbers, which we call 64-bit numbers. And the whole pace of all technology has been getting us from the old days of 16 to 32 to 64-bit numbers. Now we're suddenly compressing them again, exactly so that they can sit on a chunky laptop for someone in the field. So very interesting, and I can't give you a definitive answer because it really is still changing month to month at the moment.
Yeah, this seems like an area where the commercial sector took one avenue, and now whether it's through public investment or military investment, but the US has to create new ways to have on-platform compute at a higher level, even though that's not necessarily something that had a big value for the commercial sector. But Skylar, I really like your point that there actually is a commercial business case to be made for edge computing, and we're just not aware of it yet. But this is US Central Command provides this amazing opportunity to experiment with maybe an edge computing solution that, I mean, if you can, if it works in Saudi Arabia in an exercise with the US military, it's probably pretty good for delivering packages in Minnesota. So I had never considered that before. So thank you. What are some other areas where you're seeing potential dual use software capabilities that I don't know, speak to a different way for that everyone's going to experience computation or information technology through things that are coming out of some of this experiment that you're doing?
I think that I want to be mindful of not overstating where it is a one-to-one match, because there's always some nuance and difference between the two. But we really are watching and trying to be fast followers of each application of AI and machine learning that comes out. We are, again, I would probably say lagging behind because we want to make sure that the places where we implement it are done in a responsible and mindful way. Large language models is one where you can imagine the sheer volume of unstructured documents that exist across the department, not just in central command, that if you had a way of thoughtfully querying or asking questions out of it, you'd be able to get some really meaningful insights out of decades worth of data. But right now it would require a human going back through, finding the document, reading it through, connecting the dots themselves between these different pieces. And so there is certainly an opportunity space there that we are starting to get into the shallow end of. We are very fortunate here at CENTCOM to have Dr. Moore on hand to help guide us and maybe give us a little bit of pointers of there may be a roadblock ahead, or there may be one path that is more effective than the other. It feels a little bit, not to embarrass him, but it feels like being on an orchestra and having Beethoven as an advisor. But it helps us at least be thoughtful and precise about what application cases we use, because we're a busy command. We conducted 313 operations against ISIS in just last year alone. We need to be very precise about where we spend our time and what juice is worth the squeeze. And so what we can do is say, okay, we have this particular problem set. Let's check it against experts like Dr. Moore. Does it make sense to apply large language models? Does it make sense to apply zero shot and low shot models? Does it make sense to apply computer vision and different types of tools? Or is there a different way of going about it? And so I think that as long as we anchor it to very specific, tangible operational problem sets, we're able to be a little bit more specific about what commercial tools to even begin trying out, rather than spreading ourselves too thin across.
Yeah. I want to take that a second and come back to this idea of central command as the lab designate, because there's a lot of attributes that lend itself to experimentation there. You've got, in addition to very harsh and various weather conditions, you have a lot of gray zone activity related to smuggling and other things. You have, as you point out, it's a very busy place. You have active combat situations. You have, there's still plenty of folks that wake up every day and have to go and work on that ISIS problem set. You have great state activity. China, but especially Russia, has an active presence in the region. You have a lot of ISR collection and opportunities that have been built up over the course of 2 decades. You have even some areas where you have contested communications and some where you don't, and so you're seeing that mix, which I think speaks very well to what a lot of future areas are going to be like that people have to do business in. It's going to look more like a mix than we imagined. So when you look at the pluses and minuses of CENTCOM as a place to be doing all of this stuff, what are the things that really get in the way of scaling this elsewhere, and what are the things that really help it?
It's an interesting question. I think that the items that allow it to scale are the, as you described, the diversity of threats that we face. So we are a problem-rich environment and a diversely problem-rich environment where it is, as you described, everything from state activity and the threat of ballistic missiles all the way down to weapons and drug smuggling on the high seas and everything in between. And what that means is that we have the opportunity, for better or worse, to test solutions against a realistic environment. And because of the diversity, it allows us to do in safe but realistic ways, where you can start with a scenario and with an environment that is more controlled and manageable. If you think about the maritime context, the water is immediately off the coast of Bahrain, where NAVCENT is based, is something that is a little bit more manageable. But then if you looked at other areas around the peninsula where there may be more activity going on, you could slowly gradate or graduate a capability up to increasingly more difficult environments and see how it responded in each, rather than hopping it into a far case where you might experience a little bit more risk than would be appropriate. So because we have those daily activities to test those, and because we have that diversity of environments that will pressure test just a little bit more each time, I think that we are really particularly well suited to become a sandbox. So barriers to scaling outside of CENTCOM, I mean, in part, to be frank, is a belief or understanding that our problems are not unique to CENTCOM. I think sometimes there's a belief of otherness, that something that happens in one region couldn't possibly be applicable to another. I think that folks are starting to wrap their heads around the fact that that is not the case, that we have Chinese vessels sailing around in our waters, that we have Iranian drones out in Ukraine, that there is increasingly just this mesh of problems that all of us face collectively. But then the other one is the processes within DoD itself. It's something that is brought up over and over again. but scale is difficult when your processes are designed for capabilities that are from decades ago. If you have an acquisition process that was, oh, I don't know, designed in 1958, that might be a process that has difficulty adjusting to software acquisition, because how could they have imagined what software was in 1958? And so I think that those are some of the primary barriers. And unfortunately, it's not something that we as CENTCOM can do, but what we can do is run experimentation, bring in partners from other folks, from other combatant commands, from elsewhere in the department, to prove the fact that a solution is viable, and then raise the flag to the department when we say, we're trying to scale and we have hit a barrier.
Yeah.
And this is the barrier, and this is why it's important for us to work through that barrier. And so hopefully what we can do is more clearly articulate the most critical barriers that we as a department can get through, because we are seeing operational requirements tied to them.
Yeah, and I think that there is a future program manager in Southcom or Indo-PACOM or UCOM that is thankful that you're tackling those barriers, because they probably meet them too, and they're probably pretty sick of them. But in the little time we have left, Andrew Moore, I want to stick with you for a second. When we spoke earlier about your new role, when you were first coming into your role there, you were just sort of beginning to understand the data set that you were working with, and you wanted to figure out kind of the lay of the land. Now you've had some months sorting out what the different pieces of data you have look like, and you have a sense of your tools. What does the next year or two look like for you in terms of an objective? And does it look like a new version of Project Maven, which of course has its roots in Central Command, and now has become kind of the benchmark for the department to create AI efforts around? It was seen as wildly successful and obviously also very responsible. What does the next year look like for you in terms of creating some new capability that might be really useful here, given what you know about the data sets? And is Maven a good frame in which to understand how a next version of uniquely military AI might look like, or is it a better frame, something else?
Yes, so Maven I think the ongoing incarnations of it are a really good example of getting from what one of the pioneers of AI, Herb Simon, used to call signals to symbols, which is you've got technology, some of it exotic, some of it really, really unexotic, which can capture signals about stuff and then bring it down into digital form. Now, there's a big theme for that in making sure that once you've detected what, we often just talk about the dots on maps, like all the different systems putting dots on maps from many different sources. The next real question is making sure that you're able to do inferences about what's really happening based on finding relationships between all these dots on maps. Now, there's a technology which Sky and I have been talking about very intensively around the concept of knowledge graphs, which I understand in other parts of the military have had some success, but also had some unsuccess. Now, knowledge graphs is, in my opinion, it's what's created these trillion-dollar companies that you see on the West Coast of the United States. And it is the way that everyone works really hard to deal with the fact that data, when it arrives, it does not arrive beautifully labeled for you. It's usually a bunch of pretty ugly text strings embedded in PDF documents or on noisy web pages or social media feeds, or in 15 different formats from 14 different vendors. And so the concept of a knowledge graph is all about what might sound rather boring, but it's actually really, really cool stuff to do with making sure that you understand all the references to the same identical object coming from all of these different forms of data, so that you can form larger scale inferences based on top of them. So I think that's going to be one of the unifying themes you'll see from us, is it's the absolute important, not just of being able to ingest large amounts of data, but being able to normalize it in the way where we can actually do inferences, so that perhaps it's not just that this ship on the ocean is taking a strange trajectory, but also it's taking the same kind of strange trajectory as two other ships, which perhaps are connected in some indirect way in the knowledge graph by their financing, or perhaps by their ownership, or other secondary or tertiary or even quaternary information like that. So that in the commercial world has been the absolute game changer, which has really powered the Googles, Microsofts, and Amazons. I really want to see how we can make the best use of that for the benefit of military defense.
Wow, I would watch that show on Netflix. And that's a great note to end on. So Andrew, Skylar, thank you so much for taking the time to talk with us today, give us this view of what the future of military innovation looks like through the lens of U.S. Central Command, where you were out there creating tomorrow today. So thank you. Stay tuned to our audience. Kevin Barron continues our program with Poland's ambassador to NATO, Thomas Stikowski. I'm Patrick Tucker, Science Technology Editor of Defense One. Thanks a lot.